Hello everyone, welcome to another exciting moment. Today we'll be going to look at um, how to analyze lead nitrate as a kind of preparatory class for the forthcoming exam, the WAEC preparatory exam. So in this one, we were given a salt. The salt we are given is lead trioxonitrate 5 called lead nitrate. Lead nitrate is one of the soluble compound of lead. One of the soluble compounds of lead. In fact, lead is known to be insoluble except that of nitrate. So in this case, we have given a question here. We are going to use it to show some ways of identifying lead ion and the nitrate ion in a salt analysis. And there are so many other ways to do that, but we want to choose a particular way to get this thing done so that we can help our students that are preparing for this very exam. So in this case, we have a question here say that Q is inorganic compound. Carry out the following test on Q and record your observation and inference. So in this case, in this exam, most often they don't give you the name of the source, they will just give you a letter, just like what we have there as Q. So when they give you that, they expect you to use from the test and from your test observation, and then you'll be able to give the what inference. So in this case, let's just run through this test and see what we're likely to get at the end of the analysis. So in this case, we have a Q plus distilled water, and then divide into 5 portions. That means when you add a sample of it in distilled water and divide it into 3 portions. Now, our observation, what we observe is that we notice that the sample is soluble and then gives a clear solution. Gives us a clear solution. Now, for the fact it's a clear solution means that colored ions are not there. That means colored ions absent. Now, colored ions is characteristic of transition elements. Transition ions, they are all colored. Most of them are colored in their compound. So for the fact it's not colored, it's giving you a clear solution. It means that transition elements are not there. That's why colored ions are absent. Or you can say transition ions absent. So in this case, because it's soluble and it's clear solution, we don't know the compound there. We know that this potassium ion, sodium ion, ammonium ion, or nitrate 5 ion are likely what present. Now, why is it so? These are the salts, the ions that are always soluble in every indication. They are always soluble. Most often, they give you clear solution in their ions when you dissolve them in distilled water. So that's why we are looking at it and suspecting that since we don't know this salt and it's give us clear solution and no colored ion there, it's likely that since it's soluble, we are suspecting soluble salt. These are soluble salt in ions, soluble ions in every indication. That's what we are suspecting there. Now, in the first portion that we have there, the next thing we do here is say that we add dilute sodium hydroxide solution in drop and then in excess. In drop, we notice that we have what? Insoluble, and soluble in excess. Soluble in excess is insoluble in drops and then soluble in excess. So since it's like that, there are possible ions that normally behave like that. One of them is what? Zinc ion, lead ion, or aluminum ion. Likely what? Present. Now these are the three ions that can behave like this with sodium hydroxide, insoluble in drops, soluble in excess. So we listed them out. So since we are suspecting this, the next one we're going to do in the second one, say that from above, the second one from above, a portion of there from above, aqueous ammonium in drops and then in excess. So now we add that. What we notice here is that we have a insoluble, we have um, insoluble, and also can say and also and okay, I can say insoluble in what? Excess. So insoluble in excess, because in drop it was insoluble, and then in excess the insolubility still remains. That means the precipitate we have here, before I forget, is what? White precipitates. White precipitates. We have white precipitate. That should be white precipitate, because these are the sort of ions that will give us white precipitate with sodium hydroxide, which is insoluble. And this other one, we also have white precipitate. I almost skip this thing. White precipitate, insoluble in excess. Insoluble in excess, white precipitate, insoluble in excess. Then, since it's white precipitate, insoluble in excess, it means that zinc is what? Absent. And then lead or aluminium likely was present, because zinc ion is always soluble in excess aqueous ammonium. So since this one is insoluble in excess aqueous ammonium, means that zinc is not there. It's likely to be either lead or aluminium. So the next one we're going to look at the fourth. So to the fourth, the next one, the third portion, we add dilute hydrochloric acid. Dilute hydrochloric acid. We will notice that we have white precipitates, and then when you warm it, it will be soluble. Soluble when hot, and insoluble when cold, So what we have there is that it means that lead two ion likely present. So in the next portion there, we add a potassium iodide. When you add potassium iodide, we notice a yellow precipitate, which confirms the presence of what? Lead 2 ion. Confirmed, because lead 2 ion gives you yellow precipitate of lead iodide. And to the last one, when we add copper tetrasulfuric acid, copper tonics, and warm gently, we will notice a brownish gas liberated, a brownish gas with a strong unpleasant smell. Liberated. So this gas um, this brownish gas is coming from, it's as a result of nitrate 4 gas. And then since there's no other thing that can give us nitrate 4 gas except nitrates, that means nitrate ion, nitrate 5 ion is present, is present also confirmed. So this is what we have here. And in this case, lead oxides, lead chloride is always insoluble. It gives you white precipitate. And lead, one of the things about lead is that when the precipitate, when you heat it, it will dissolve in hot, and then when the substance is cold, when the liquid is cold again, it will form a precipitate. So this is just a basic simple way of analyzing silver lead nitrate. Thank you so much. And if you have not subscribed, I would like to um, see your comment. Just tell us the country that you are watching us from, so that we can always thank you for coming around. Please subscribe if you have not. Thank you so much.